Hello everyone, this is Mrs. Padmashri from SNS College of Engineering. Today I'll be discussing about the continuation of my lecture series, Convolution Neural Network. The last architecture which we have discussed is VGG network, the VGG architecture, and today the same from the convolution neural network we have the another architecture ResNet. So this ResNet which overcome the problem which occurred in the VGG net. So let's move on to the slide and discuss how this ResNet is solving the problem which happened in the VGG network. So before we start, what is the residual network? The ResNet is a deep neural network. We can say it's a deep learning model which is used for computer vision application. Okay. It comes under the convolutional neural network architecture, designed mainly used to support the thousands of convolution layer. Short form, we can say ResNet, the residual network, is a type of neural network architecture introduced in 2015. It was designed to solve a problem of vanishing gradient problem which is occurred in VGG network. So which hindered their performance of large scale image recognition system. So the problem which had occurred in VGG, which has a large data set, say for example, thousands of classification data set was given in order to identify the thousand of images. So it affects the network speed. It is we can say it is inefficient. So how we have to overcome the problem here with the help of residual network. So the vanishing exploiting problem. It is every subsequent winning architecture uses a more layer in deep neural network to reduce the error rate. So when we increase the number of layer, there is a common problem what we have associated with is called exploiting gradient or vanishing. This causes the gradient value becomes 0 or 2, either it becomes 0 or too large. This causes increases the number of layer, the training and error rate, testing rate, training rate also increases. So in order to solve this problem, vanishing, exploiting gradient problem, the architecture introduced called residual blocks. So it is using the technique, the important technique called skip connection. The skip connection consists of various, that is, it has a activation of a layer to further layer by skipping some layer in between. So skip connection connects activation of a layer to further layer by skipping some of the layer in between. So this forms a residual block. So the ResNets are made by stacking the residual blocks together. So how this ResNets are designed? Skipping some of the layers in between, then directly we are going to connect with the other layer. So this is the concept given so that it just make a stack like structure. We'll just see how this is happening. The approach behind this network is, instead of layers learning the underlying mapping, we allow the network to fit for residual mapping. So in say h of x, the initial mapping, that's the network fit f of x is equal to h of x minus x, which gives h of x is assigned to f of x plus x. So this is the function equation. So how we achieve that? We will just see here the skip connection, which is also called as shortcut connection. Okay. So which is we can relate this with a example like application like when we travel by the road, we are just using the bypass road, right? So what in between the places that we are skipping it, and directly we are going to reach to our destination in a very short period of time. The same thing. So whatever uh, thing, the layers creating the problem, we are just skipping those layers and directly we are connecting to the destination. See here, x is there, f of x is there. So you can see here, weight layer 1, weight layer 2. Between these two, there is a RELU. RELU is there. RELU. So directly x, we are going to connect with the f of x plus x. Okay, so we are just skipping these two weight layers in between. So x is representing the identity. So f of x plus x, directly we are going to reach to the another layer. So this is one of the advantage of adding this type of skip connection is if any layer hurt the performance of architecture, we are just going to skip that layer, or we can avoiding that layer, then it will be skipped by the regularization. So if any of the layer hurt the performance of architecture, we will be skipped by regularization. So the result in training a very deep neural network without the problem caused by vanishing or exploiting gradient. So this will help to overcome the problem. Thank you. The rest will be discussed from the next lecture series.